For tonight's Green Report, we go to Phoenix, Arizona, where temperatures have been over 100 degrees Fahrenheit for most of this month of June. And 9 of the first 22 days of the month were 110 degrees or hotter, including 5 consecutive days. And thanks to climate change, that kind of extreme heat is becoming more and more normal across the United States. National Weather Service estimated that between June 16th and June 22nd, 32 million people saw temperatures in excess of 100 degrees Fahrenheit in the United States. 7 million people saw a temperature at or above 110 degrees Fahrenheit, and 159,000 people saw temperatures of 120 degrees Fahrenheit or more. This particular heat event is caused by what's called a heat dome, which is also driving the historically large wildfires in the western United States. According to climatesignals.org, looking at records going back to 1958, researchers have found that almost all of the high-intensity heat domes, like the one we're seeing right now, have occurred since 1983, and an overwhelming majority have occurred since 1990. For more on this, I'm joined now by Dr. Michael Mann, Distinguished Professor of Meteorology, Director of the Earth System Science Center at Penn State University, and author of Dire Predictions: Understanding Climate Change. Dr. Mann, welcome back to the program.
Thanks, Tom. It's good to be with you.
Thanks for joining us. You recently told members of the Democratic National Committee that there isn't much need for climate data and models anymore because we're seeing the impacts of climate change everywhere. Can you give me some examples?
Yeah, well, what I said wasn't quite that dismissive of data and models. What I actually said was that we no longer need the sophisticated sorts of tools that we used to have to use to detect the signal of climate change, because that signal has now fully emerged from the noise. So as you allude to, the record-breaking heat that we've seen in the U.S., we see all-time records broken for the hottest day on record for various locations around the country. Those records are being broken at twice the rate that they were a few decades ago. We have seen a tripling in the extent of wildfire in the western U.S. And so when you see those sorts of numbers, a doubling of extreme heat, a tripling of wildfire, the signal has emerged from the noise. You don't need fancy, sophisticated statistical tools to see the impacts of climate change as they are playing out. And we are indeed seeing those impacts play out in real time now.
So we have this heat dome over much of the United States right now that is drying out the West and causing all these problems. What exactly is a heat dome, and what are the impacts of that sort of thing on our climate and on our weather?
So a heat dome, typically it's a large high-pressure center. So low-pressure areas, as we know, those are associated with storms, and you have lots of cloudiness, and you have rainfall. High pressure is associated with fair weather, and often we think of high pressure as, high-pressure conditions as being, fair weather conditions, good conditions. Unfortunately, in the summer, those high-pressure systems are also where we find some of the warmest temperatures on the face of the Earth. Typically, you find a very strong, well-pronounced belt of high pressure in the subtropics, somewhere in the vicinity of 30 degrees north or 30 degrees south of the equator. So the Sahara Desert, the desert southwest of the U.S.
That's the tropics of Cancer and Capricorn you're talking about.
Yeah, that's where you tend to see that high pressure, and it's associated with sinking air. It's the sinking of the same air that rises within the band of storminess that we call the intertropical convergence zone. All that rainfall and cloudiness in the deep tropics, eventually that air sinks, and it sinks as dry air with clear conditions, high pressure at the surface. Now, that subtropical band of desert-like conditions is literally expanding. So the sorts of conditions that we associate with the Sahara Desert or the desert Southwest, those conditions are expanding into higher latitudes, well into the middle latitudes of North America. The 2003 epic heat wave in Europe, which killed 30,000 people, and they don't have the sort of resources to deal with heat like we do here in the U.S. They don't have widespread air conditioning, for example, in many parts of Europe, and 30,000 people perished. That was an example of one of these high-pressure subtropical systems that migrated to very high latitudes, all the way into the UK. And that is consistent with what the models have been predicting for decades. For decades, we've said that one of the clearest responses of the circulation of the atmosphere to climate change is going to be a poleward migration of that belt of high-pressure sinking air. And that's what we're seeing.
Wow. How much of a factor is the El Nino and this particular heat dome that the U.S. West in particular is experiencing?
So the El Nino signal has pretty much subsided. El Nino is no longer playing a dominant role in the weather patterns that we're seeing in North America or elsewhere. In fact, typically the strongest influence of El Nino on weather patterns is in the winter, is in the northern hemisphere winter. So what we're seeing right now can't really be related to El Nino in any meaningful way, but again, it is consistent with the increased prevalence of dry, hot conditions that we expect to see as we continue to warm the planet and change the climate.
Do the forest fires that are happening underneath this heat dome, I mean, they're generating their own heat and they're also putting particulate matter in the air. I don't know if that cools or if it traps heat. Are they part of a feedback loop, or is this merely a, you know, the secondary effect of all this heat drying out the wood so it burns?
No, you're exactly right. There are very important we call feedback mechanisms here, where you warm the soil evaporates more moisture, what little moisture it has, in the case of California, back into the atmosphere. It becomes drier, and that means that the surface has one less means of cooling off. Evaporation is one way that the surface tries to cool off. You take away that ground moisture, that soil moisture, and those soils are going to warm up. The surface is going to warm up even faster, and it's then therefore going to dry out even more. And so it is indeed a positive feedback loop. Sounds like a good thing. It's not. What we really mean there is a vicious cycle where the process just intensifies itself. And so it's not coincidental that in the midst of the worst drought in California in 1,200 years, that's what the paleoclimate scientists tell us, and even a big El Nino event wasn't enough to really make much of a dent in that drought. And now we have the summer conditions. We're seeing record level heat, record level drying. It's not rocket science. When you have record heat, when you have record drought, and you have all of this fuel, these weakened trees and plants from the drought serving as fuel, well, you're going to get more and more intense wildfires, and that's what we're seeing play out.
You said the worst event in 1,200 years. You know, when I would say something like that to people like Mark Morano, he'd say, yeah, 1,200 years ago, see, the climate change has always been with us.
Yes.
Was 1,200 years ago a local event, or is there some pattern here that is additive to the man-made stuff?
It's indicative of the science speak that we scientists tend to lapse into. So when we say the worst drought in 1,200 years, what we really mean is we can only go back 1,200 years with the data we have, with the tree rings we have, with the paleo data. We can only go that far back. And as far back as we can go, this is the worst drought on record. So that's really what it's telling us.
So, wow. So it's the worst record that we have any evidence of in that area. What other kind of events that we're seeing on our televisions can be directly attributed to man-made climate change?
Well, it sometimes seems counterintuitive, even paradoxical, but it's quite clear that as you warm the planet, as we've already said, you're going to get more widespread drought in the summer over a large part of not just the subtropics, but the middle latitudes. But at the same time, a warmer atmosphere can potentially hold more moisture. And so if the conditions are conducive to rainfall, if you have rising motion in the air, then you're going to have more moisture that can be condensed into what we call rainfall, and you get more intense rainfall events. You get more flooding. So while it might seem like a paradox, it isn't. You get more widespread summer drought in the middle latitudes, but you also get more intense flooding events, like what we're seeing in West Virginia, a 1,000-year event, like what we saw earlier this year in South Carolina, a 1,000-year event. Texas, another 1,000-year event, the flooding we saw earlier this year there. When you get this many 1,000-year events, events that shouldn't happen more often than once in 1,000 years, you know something is happening.
I was in France the week before last, and the French news, when they talk about the flooding that was going on, they would just routinely, put it in the context of climate change. I mean, it's just it's part of the normal discussion, the dialogue there. Why do you think that the mainstream American media, the corporate American media, is totally avoiding making the connection to climate change with these floods in West Virginia, the wildfires out west, all this stuff? Those words, climate change, just seem to be absent from our television screens.
Yeah, and that is true to some extent. There are some media outlets that do a great job, RT America obviously being one of them. MSNBC, Chris Hayes, and others there have done a pretty good job, in my view, of connecting those dots with these sorts of events and talking about climate change in that context. But at the same time, a lot of, when you watch these networks, you'll see a lot of advertisements from ExxonMobil, from the American Petroleum Institute, from the Koch brothers. Koch Industries now is advertising on these channels. And so they're getting a lot of money from the fossil fuel industry in the form of advertising. And whether that may lead them to not want to upset their sponsors by talking about climate change, because ExxonMobil doesn't want them talking about climate change. The Koch brothers don't want the networks talking about climate change. They don't want them connecting those dots for the American people. Right. And so there is a potential conflict of interest there.
Yeah, it certainly seems so. Dr. Michael Mann, it's always a pleasure to have you with us, sir. Thank you.
You too, Tom. Thanks.